Hi, folks. Welcome back. It's my pleasure to be here with Yan Michalevsky to talk about his work at Anjuna. My name is Kevin Riggle. I spent about a decade working in cybersecurity and privacy, most recently at Stripe and Lyft, and have set out on my own, got my own little consultancy, Complex Systems Group. I've got the shirt here. Yan is CTO of Anjuna Security, one of the sponsors here today, yeah?
Yes, indeed.
Great. Who are doing some super cool stuff around confidential computing. We've been talking as a community about privacy-enhancing technologies for a number of years. We're starting to see them go from theory to production. We've got companies like Google and Apple rolling out differential privacy techniques for things like the COVID tracking apps. We're starting to be able to solve problems with these that we weren't able to solve before and provide a certain level of safety. We've decided that maybe collecting all of this data and keeping it in the clear the whole time is not the thing we want to do. And so as we put more protections in place, we're able to use these technologies to achieve that. But it's a huge space. There's a lot of there's a lot of greenfield. There's a lot of potential moving parts, and differential privacy is only one set of techniques. So, Yan, you've been working at Anjuna on something you're calling confidential computing. Can you tell us a little bit about what that is?
Yeah, definitely. And first of all, thank you all for attending. Thanks for coming so early in the morning. So I really appreciate that. So yeah, confidential computing, I guess, falls into this general trend of enabling to still work and process data and do useful things while keeping your data private and not exposing it. So it kind of falls into this broad trend.
Yeah. Keeping your data private from whom?
So there are all kind of use cases, but what we're specifically focusing is keeping it private from public cloud operators or sometimes insiders. Sometimes it can be also companies that are deploying workloads on the cloud, and what they're interested at is something interesting. They basically want to tell their customers that they're processing their data, they're doing kind of offering the SaaS services, but they don't have actual access to the data itself.
Right. What kind of use cases are you finding for this technology? Like when a customer comes to you, like what pain points, especially around privacy, are they trying to solve?
So we see a couple. I guess one prominent one is this ongoing move to the cloud. So it might be surprising for organizations that are entirely in the cloud, but a lot of the industry or a lot of fintech, kind of more traditional organizations are not yet fully in the cloud or even not at all in the cloud. For instance, the banking industry is still largely struggling with that. But everybody understands they need to move to this infrastructure because of all the functionality it offers. So everybody who wants to move to the cloud but have all kind of regulatory constraints or basically really worry about the privacy of the data, they're going to move there. So that's one use case around which we see a lot of traction. Some others include, for instance, SaaS companies that, as I mentioned, want to provide better privacy guarantees to their own customers because it just enables them to onboard customers that are very sensitive to that. So it enables them to have more business. And another one that we see is around the blockchain industry and crypto. And that's because there's a lot of private data there that they're processing. There are more of a security aspects that are relevant there rather than privacy per se, but that's another domain where confidential computing can be really helpful.
Okay, yeah. So that's an interesting point that you touch on where this work sits at the intersection of sort of like security and privacy. What's it been like working at the intersection of those?
Yeah, so that's a good point. It's basically security for privacy.
Okay.
It's essentially there are a couple of approaches. I guess let's try to bucket them to privacy that I personally see in the industry. So some of them include essentially trying to prevent having sensitive data or private data to reach essentially workloads or infrastructures that you don't trust. So you may want to scan for sensitive data and just avoid deploying it. Other approaches, like confidential computing, they basically say that you want to deploy this data, but you want to keep it safe there. So you need the security for that. And that's essentially this intersection between security and privacy. And what confidential computing does is enabling you to kind of fully shield workloads and process very sensitive data without exposing it.
Okay, interesting. So we were talking a little bit about this on our prep call, but concretely what you're able to do, if I understand it right, is sort of take an application, pretty much any application that you might want to deploy on cloud, and that can be any of the major public cloud providers, AWS, GCP, Azure, and use the functionalities that the public cloud providers give you, like AWS's Nitro enclaves, for example, to run, and you let people run this arbitrary tech inside there. So are there places that you see this intersecting with other kinds of privacy like tech?
Yes, so I think in general, what everybody's pretty much kind of trying to do is make those things simple to consume. Right. Whether it's finding private data, whether it's protecting the private data. So if there are some technologies that enable those things, and there are some techniques that you would like to use, people will only use them if they're easy enough to consume. Okay. So like a lot of the companies in general in the space, and not only Anjuna, are essentially focusing on how to make those techniques for protecting data or identifying sensitive data very easy to deploy. Okay. And what we're bringing to the space of confidential computing is exactly that. Essentially, there's this very interesting technology that people want to use, people are looking at, but there was a big bar to entry. So right. People couldn't consume it without the software stack that would make it simple. Right.
And so conceptually, you could run any other sort of like privacy, application, like whether it's a code scanning application or using your technology and get increased privacy guarantees out of this? Is that true?
Actually, you're bringing up a very interesting point. Yeah, there's some complementary aspects to different technologies, and where it can help actually, like now just thinking about it, and it came a couple of times throughout our journey, is where confidential computing can guarantee integrity. So for instance, one interesting thing you would like to ensure is that if you run some scanning or you're kind of scanning something with a privacy tool, you want to make sure that it's not tampered with. Right. Because one attack vector would be, an attacker wouldn't want to kind of prevent from running the scanner, because that would be very noticeable. Right. But an interesting attack would be basically kind of tampering with the results and outputting something that says, okay, everything is clear, whereas you're actually leaking some private data. Okay. So running such a scanner in confidential computing potentially can provide the integrity for that, ensure the integrity of the workload, and ensure that the results that are output are actually correct, and you ran the original workload that hasn't been tampered with by an attacker. Okay. So that's where this security can kind of help ensure privacy.
Right. Would you also potentially worry there about an attacker tampering with the underlying data that something was being run over?
Yeah, exactly. Basically, all aspects of integrity, and where it's crucial for ensuring you process the original data and not something else. Right. That can also be addressed.
Okay, interesting. Are there other tools or techniques in the space, either privacy or security or just general IT ones, that you've seen this pair really well with?
Yeah, I guess there are different approaches that are complementary. Confidential computing and what we're doing in the space is essentially focusing on kind of running the workload without changing it. It's kind of running the original processing on the data, but without basically shielding it from all the rest of the infrastructure, but without really changing it. There are approaches that intervene with this processing. For instance, things like tokenization or tools that are transforming PII data into some synthetic data that you can operate on. So those can be complementary approaches. You can apply both to the data and kind of get better privacy using this combination. There are also cryptographic approaches that are worth mentioning. For instance, whoever heard about homomorphic encryption, that's a technique that is, rather than using the hardware technologies, basically trying to provide privacy for data in the cloud by encrypting it before it's being processed. So there are multiple approaches. Multi-party computation is essentially trying to get rid of a single point of failure and decentralizing the trust in one host that can be compromised to multiple hosts.
Right. Why would you choose to use confidential computing over one of these, or like, why would you choose to use them in combination?
So with some approaches, it's complementary. With some approaches, it might be more competitive. For instance, homomorphic encryption and confidential computing are to some extent competitive, but there are different advantages to each one of them. What I personally like about confidential computing is that it's very pragmatic today. It's a very pragmatic approach, first of all, because of the high performance it can provide. With some other approaches where you change in how the data is being processed or can introduce in some things in between, you kind of affecting performance a lot, and that can be unacceptable to some customers. Whereas confidential computing, the whole goal is that you're still kind of using the same processor, you're running the same workload, and if you do things right, you can do it without impacting performance or barely impacting it.
That was something we were talking about on the prep call, which really impressed me, that I guess the way that I had understood these techniques to work was that you really wanted to put the smallest little piece of your processing that you could in these enclaves, but that's not the way that you're doing this.
Mm-hmm. Yeah, and it relates, I guess, to the paradigm specifically around the Intel SGX, which is one of the technologies in the space. SGX stands for Software Guard Extensions, and that's essentially the technology that kind of kicked off confidential computing in 2015. It essentially provides secure enclaves, and you can create small enclaves. You can create parts within the application that are protected and shielded from the rest of the application and from the rest of the infrastructure. The problem with that, there are multiple problems with that. One practical hurdle is that it requires essentially re-architecting your infrastructure and your applications, and that's something that practically cannot happen at a large scale. Or sometimes it's just something you cannot do because you're using some third-party or even closed-source software that you just need to run as is, and if you cannot re-architect it to work with the small enclaves, so you got to lift and shift the whole workload. In other cases, it's just very hard to reason about a security perimeter kind of within the application versus what you leave outside of the security perimeter and what are the guarantees it provides. And I'll give a concrete example. That's actually, people tried to implement it and implemented it, but there are all kinds of problems with that. For instance, with network security, one of the crucial things to protect is TLS termination and the TLS connections between different applications. So, and the crucial piece there is the private key that enables you to do the TLS handshake to establish the connection. So that's the piece that, if this piece is stolen, basically an attacker would be able to mimic your workload and kind of pretend to be this application that some other workload trusts. So it's crucial to protect this key. And there were attempts to basically kind of just put this TLS termination within a small enclave. There are all kinds of problems with that. First of all, there might be performance issues because you're always kind of switching between this execution within confidential computing and outside of it, and it might introduce, those switches can introduce some performance penalties. The other one is around kind of the security of that, because any attacker that is able to inject code into the unprotected parts of the application would be able to basically use it as what's called an oracle. They would be able to kind of query this enclave, ask it to do the handshake for them, and then they basically see the whole network connection and the data that's passing over it in the clear.
Right. Okay. Okay. So you've come to the conclusion that you have to protect the whole application. Basically, you have to put the whole application into these enclaves.
Yeah. Our take is that it's a more pragmatic approach.
Okay. Yeah. Yeah. That makes sense. And you found ways to do that while maintaining the performance that you would expect, or coming very close to the performance you would expect from the...
Yeah, we worked a lot on that, and I guess the couple of the things we can point to is the work we did with some of our partners. So one of the early partnerships at Anjuna was with Redis Labs, and that's known to be a sub-millisecond latency database. So we were able to maintain those guarantees. And that was like a big milestone for us because it shows that you can run run very performance-critical applications within confidential computing without affecting this kind of performance.
Right. And SGX, Intel's SGX, is one of the early technologies, but there are now technologies that people are moving towards, like, I think, and remind me, AWS Nitro is one of the names that sticks in my head, and
yeah, there are a couple of technologies in the space. So Intel SGX was the first one that came to the market, and then shortly after, AMD released what's called secure encrypted virtualization, which is another hardware-based technology. And about 2 years after, Amazon came out with Nitro enclaves.
Okay.
So that's a technology that's specific to the Amazon cloud.
Okay. So there you're sort of like, you've got to use AWS or nothing, but does that provide like better performance or better security guarantees, or just like advantages over these older technologies?
It's different takes on how you should do confidential computing. So obviously, the two big processor vendors, Intel and AMD, they just implemented their different approaches because each one of them wanted to kind of provide something unique to their processor. With Amazon Nitro, their take was that they want to do it at their infrastructure layer and the hypervisor layer. It's essentially not based on the hardware capabilities of a specific processor, which has the advantage of kind of enabling them to provide it across different platforms and across different processors, including Intel, AMD, ARM. So it's a slightly different take on confidential computing. Okay. And it's more of a kind of hypervisor level protection.
Interesting. So on the one hand, you have to use it on AWS, but on the other hand, you can use it across, like, it sounds like quite a wide variety of the like EC2 instant types, and it's very generally available at AWS.
Yeah, it's generally available for everything that's part of the Nitro infrastructure. Essentially, all the EC2 Nitro instances, which is the new infrastructure that everything is moving into on Amazon. So we're going to see it available on all the instances in the future.
Nice. How about the other public clouds, like Azure and GCP?
Yeah, so Azure adopted Intel SGX early on. And yeah, so that's kind of the main technology that's available there.
Okay, nice.
But also looking at other technologies as well.
Okay, interesting. Are they like developing their own Nitro equivalent, or?
No, they're essentially, their approach is mostly to work with the processor vendors.
Okay, interesting. And how about GCP?
GCP are deploying confidential computing using AMD's secure encrypted virtualization.
Oh, interesting. Okay.
Yeah. So each cloud kind of picked a certain partner to work with and provided a different solution for confidential computing. And it actually creates an interesting opportunity for us and something important to provide in the space, which is the cross-platform layer.
Right.
That enables you to have the same user experience regardless of the platform that you're running on.
Nice. And so Anjuna wants to provide that software layer.
Yeah. We work on all different on all the different major clouds with all the different technologies, and enable you to run workloads and confidential computing regardless of which technology particularly is present on this cloud.
Nice. Because the thing that you were talking about needing to fully re-architect the application in the original vision of this was pretty, I don't know, daunting if you were, looking at this as a, like software service vendor where you've already got a big application and you, want to roll this out. And so Anjuna is really providing the, like, what would you call it, like a platform, like library, like infrastructure?
Sometimes we like to think about it as kind of the VMware for confidential computing. Yeah. And I'll explain the analogy. Essentially, you have technologies, you have kind of hardware level or kind of low level technologies that can provide interesting guarantees. So for instance, virtualization is one, right? But virtualization is not really usable if you don't have some software stack or the hypervisor software to enable leveraging that, even if you have the processor instructions for that, like VTX or AMDV. So you need a software stack to consume it. So that's kind of how we like to see ourselves. Basically, the software stack that enables you to use those hardware or infrastructure level technologies.
Yeah, nice. It enables you to use them, I guess, not just on like an individual machine or on like bare metal that you're running, but across the public cloud, basically.
Yeah, yeah, both on the public clouds and on-prem as well.
Oh, it does work. You do work on
yeah, it works on-prem. Just in terms of the focus and the traction we see, it's a lot of it is relevant in the public cloud because that's where you kind of shift into an infrastructure you don't control.
Right, right. And like nobody wants to rack and stack servers in 2022.
No, nobody wants to maintain that.
Not if you can at all avoid it. This is super cool. Like, as a technologist, this is the kind of thing that I'm like, ooh, what is this going to be? But it also feels like we're really early days with this tech still, and there's a lot of greenfield left to explore. Where do you see this going in the next like 5 to 10 years?
That's a great question. I guess it's hard to predict, but what we see is essentially a lot of work on the kind of convergence around the security models around that. So for instance, previously I mentioned a couple technologies like Intel SGX and DSCV, and they had slightly different security guarantees in the beginning in terms of the attack vectors they can address. There were some subtle differences. And essentially with time, they're converging, I guess, on similar security models in terms of which threats they protect against, what's outside of the threat model. Just because of kind of the practicalities they need to face and kind of the learnings and all the feedback they get from customers over time. So we see that trend. I guess what will be interesting is kind of to see, well, Amazon is a major cloud, and currently they're providing their own solution for confidential computing. It would be interesting whether in addition to that, they also provide access to the hardware level solutions like SGX and AMD SAV, because that would enable basically people to choose kind of the technology they want to work with. And we'll probably see more solutions, kind of more sophisticated solutions in terms of the software stack that enable to use that, starting with essentially solutions, say like ours, that provides a lift and shift, but also going up the stack, and seeing solutions that leverage confidential computing to provide basically a customer-facing service, basically SaaS services that potentially enable you to use confidential computing easily or do something useful on top. For instance, tokenizing your data within something that's protected by confidential computing and ensuring the original data that comes in is not exposed. And we can think of many examples of kind of useful SaaS services that can build on top. So that's probably the future of that.
Cool. One final question, and then I'll open it up for Q&A. Since we've got a lot of privacy technology companies in the audience and privacy technologists, are there places where you'd like to collaborate with other companies in the space or like see people build complementary offerings?
Yeah, definitely. So previously we talked about how privacy solutions and scanners can be combined with that. So I think those are interesting partnerships to explore. Companies that are providing that can benefit from integrity guarantees that this technology can provide. And also for solutions that attempt to protect PII or detect private data. So was just talking with one company named Piano. So they are protecting PII data by basically enabling you to mark this data and tokenize it in a way that basically creates synthetic data that you work with. And they're interested in this kind of stuff because that would enable them to basically do the original data processing in isolated and protected environments and provide the guarantees to their customers that even they don't see the data as it comes in into their solution.
Nice, nice. Are there questions in the audience or questions online?
If anyone has questions, you guys can come up here, or I'll repeat your questions for you so that the folks virtually can hear your question. Anything about confidential computing or pets?
Here we go.
Thanks for that informative talk. Yan, I'd love to hear more a little bit about the use cases you might have for like more traditional institutional like financial or health companies and how they're using Anjuna either on-prem or using it in the public cloud, and like how that shift has happened and they're willing to embrace cloud compared to staying on-prem or anything like that. Thanks.
So you mentioned health. So I guess in the healthcare industry, there are interesting use cases to mention. One example I can give is, and it probably will take some time because in this industry, it's kind of like tends to be more of a follower for cutting-edge technologies rather than an early adopter. But I think some interesting things to look at include essentially patient privacy, and also protecting valuable data and data sets. So just to give one example, sometimes you'd like to say run some query on a genomic data set to identify whether a certain genotype can cause some disease. There are two private pieces, very sensitive pieces of data here. First of all, the query that can expose what conditions a patient may have, and also the data set, essentially the data set that you query against that contains aggregate genomic data, or maybe a kind of commercially valuable intellectual property. So there are those two pieces to protect, and what you can do with those kinds of technologies is essentially to ensure that both the query, what you're asking, is kept private, and the data set is protected. And you can run it essentially within confidential computing, making sure that the genomic data that you use to run the queries against and the query that goes inside, they're both only opened and are in the clear inside the confidential computing environment and not outside of it.
Cool. Next question.
Yeah, so I'm having a little bit of trouble with acoustics in the room, so apologies if you addressed this already, but literally yesterday, the White House published Advancing a Vision for Privacy-Enhancing Technologies. What do you think is the possibility for stimulation in the market by the government and or partnerships with the government?
So I guess where it's interesting to kind of the context that is interesting to examine this scene is regulation around access to different types of data. Things like PII, private information. This is something that creates a lot of kind of hurdles for companies and friction in terms of dealing with private data, identifying it, and essentially being responsible for a very large perimeter. Where this technology can help is essentially narrowing down the scope of what you need to audit and what you need to examine to comply with government regulations. Because what we're interested usually is the security or privacy around the data itself, and not the entire infrastructure and all the different workloads you have. So I hope it's answering your question a little bit. So that's essentially where it can, on one hand, enable pretty strict regulation that would ensure the privacy of users' data, but on the other hand, enable us to kind of move quickly in terms of deploying things and being very pragmatic around how to protect it and not create too much friction that would just prevent kind of innovation and progress.
Do we have questions online? Lourdes? So we'll take a question from Deborah while check.
Yeah, while she looks, I'll ask.
Great.
What is the question? The question is, with privacy-enhancing technologies, for a long time, it's been that you could get it working really well in the lab, but replicating that outside the lab, and then even being able to replicate the same processes from one business unit to another, or from one company to another company, might be a different environment. Are you finding there's a better pipeline for privacy-enhancing technologies to the market these days compared to the past? Basically, what's the state of getting privacy-enhancing technologies to a point where they can be productized and embedded into engineering?
So that's a good question, and also a big question. And I guess it's something we see with different technologies, different privacy-enhancing technologies, not only confidential computing, but also MPC, multi-party computation, fully homomorphic encryption. Essentially, looking at several years ago, essentially there was this research phase. There was a lot of research going on, both around the FHE and confidential computing and kind of early instances of secure enclaves around MPC, and kind of came to a point where there are all kinds of protocols and technologies, and now we need to productize them and make them practical, because otherwise you cannot deploy them. And I think that's the phase we're at right now. Essentially, you have multiple companies, and just in terms of kind of the different companies that are showcased there, there's Anjuna, Triple Blind is another company that's making some privacy-enhancing technologies easy to use. So where we're all going with that is essentially addressing exactly what you just mentioned, taking it from the lab and enabling an easy deployment of that. And that's where, for us, for instance, it was very important to engage with customers early on, kind of since the early days with the first versions of the product, because it just provided the feedback that was necessary to make the product better and very usable. And the user experience around all of it is super important.
Well, and I think also from our conversation, it seems to me like confidential computing is really the furthest along of most of these, where like I was just looking at a bunch of MPC, multi-party computation libraries the other day, and they all have big warnings on them, like, this is research code, do not use in production.
Yeah, definitely. I mean, generally, the problem with the challenge with cryptography, you don't want to re-implement it.
Yeah.
For instance, with the cryptographic libraries, you want to use OpenSSL or a couple of other libraries that are very battle-tested, because that were usually what's broken is not the cryptographic scheme itself, is not the math, it's often the implementation. So cryptographic techniques pose this risk of kind of incorrect implementation, and using something very cutting edge makes me nervous.
Yeah.
So so that's where kind of that's where sticking to very battle-tested cryptography, simple cryptographic techniques has its advantages, and confidential computing essentially just uses pretty boring AES encryption, public key encryption, nothing too fancy in terms of cryptography, but it uses a different computer architecture that we understand very well and can deploy with good performance very pragmatically, and that enables essentially getting a very good level of privacy without doing something that hasn't passed the test of time.
Thanks. I think we have one final question.
Hi, Yan. Thanks for the
two.
panel.
Great, yeah.
Thanks for the panel. I just wanted clarification a bit on the product. Is it something that's sort of meant to replace a cloud solution like AWS Nitro Enclave, or is it something that's meant to be like a software layer placed on top of it or used in conjunction with it to abstract away like the API and stuff that users need to interact with?
So it's the second and the third. Yeah, it's not replacing, it's using what the clouds provide in terms of the underlying technology, and introduces a software stack that makes it very consumable and easy to use, and also abstracts away some of the technical details, especially where you're dealing with the details that are slightly different between the different clouds or technologies.
Okay, so the user gets to select which cloud platform they want, like AWS.
Yeah, essentially we don't make this choice for the user, because the users are usually picking the cloud not necessarily for this feature. They already chose the cloud for multiple different reasons. It might be one of them, but they pick an infrastructure because of all kind of considerations. So we have to essentially work with what the customer has chosen in terms of the infrastructure they want to run it. And that's why we want to support all the different infrastructures.
Okay, so you don't spin up the infrastructure on their behalf, like you don't spin up the EC2 instance, right?
No, we don't do it.
Okay,
We're essentially enterprise software, so we give software and the customer deploys it. And it's actually very important for security and privacy as well, because we don't want to be in this loop of trust. We just provide the tools, but we don't want to touch the customer's data.
Thank you for the clarification.
Thanks.
We have a couple of questions from the virtual component of this event. Most of them are about pets in general and not specific to a specific pet. We have one from Christine Task from Nexus. I know that she was also at the White House OSTP working group that was mentioned. We're involved in that as well. We are going to respond to that after this event. So we have a working group going. That's a tangent. But Christine Task from Nexus asks, what sort of practical utility needs do you see for synthetic data approaches? And then we have Hanipa asking, which pet do you think is most commonly used today? I haven't seen any studies that would quantify that, so I don't know if you guys are more plugged into that as someone who is a vendor in this space and tracking the market. Thank you.
Sorry, can you repeat the first?
Sure. What sort of practical utility needs do you see for synthetic data approaches? From Nexus, Christine Tass.
For synthetic data, I guess mostly, and I'm not an expert in this particular space, but from what I've seen, mostly enabling kind of research and experimentation with data. For instance, for data scientists with synthetic data that doesn't expose anything sensitive. So that's one of the utilities of that. For the second question. Different domains actually started exploring first different technologies. For instance, multi-party computation is one privacy-enhancing technology that is widely used in the crypto and blockchain space. Just because this space is also very interested in cryptography, naturally, and this is something that's very prevalent there. Confidential computing is prevalent across the different clouds and users of cloud infrastructure because it's available there, and it's also essentially enterprise companies are very pragmatic about their security. They're cautious with new techniques and they want cryptography that's battle tested, so they tend to gravitate towards those approaches that would enable them to deploy essentially the workloads they're running nowadays with minimal changes and without affecting how they work. So this technology is suitable for that.
Thank you for that. I think we're good in terms of online questions. There are a whole bunch of comments thanking you for this insightful panel. And so on behalf of the attendees here and TROPT, I thank you both gentlemen for such an excellent fireside chat.
Thank you.
Thanks. Thank you. Thank you.